With this. So the first step is to find out the TAS, right? There are two different methods to find TAS here. The first method number one, is by using the equation. And the equation is true airspeed is equal to rectified airspeed, which is nothing but the calibrated airspeed. So if you refer to older textbooks, if you refer to the aeronautical AME textbooks, the older ones, and even I believe the aviation textbooks, it's represented as rectified airspeed. So it's now we call it as calibrated airspeed plus calibrated airspeed, and we kind of increase it by 75%. So multiply with 1.75 into your flight level divided by 1000. Substitute in this equation and you will get the true airspeed. And we will be looking at the CX3 part of it. So that goes to the method 2, using your navigation computer. And obviously we are trying to find out the airspeed here, which means in the nav computer you have to navigate to the Airspeed tab. Alright, so let's do that now. So as I've mentioned earlier, if you don't have the physical calculator with you, you can always access your CX3 online by just googling CX3 online, and then they'll give you the prep for that. Right, this is how it would look like. Yes, so in that, let's very quickly navigate to the Airspeed tab. This is the 5th tab, and in that you can see TAS, outside air temperature, Mach number, total air temperature, calibrated airspeed, and pressure altitude. Now, unlike in the previous question, here the outside air temperature is not given, but they have given you the flight level at which the aircraft is cruising, and they have also stated that the conditions are ISA. But let's see how that helps. So under ISA conditions, the outside air temperature at flight level 55, which is a pressure altitude of 5,500 feet, is, let's use your met knowledge here, as we know that we go up, there's a lapse rate of 1.908 degrees Celsius per 1,000 feet. Let's take it as 2 degrees Celsius per 1,000 feet for ease of calculation. So that brings us to the mean sea level temperature under ISA 15 degrees Celsius minus 2 degrees Celsius for every 1,000 feet, so it is 5,500, therefore it is 5.5, and that brings it to 4 degrees Celsius, right? Perfect. So the outside temperature is 4 degrees Celsius. Let's now get back to your CX3. The outside temperature is can end up 4 degrees Celsius, but before doing that, again, let me re-emphasize this, because you need to look and make sure the unit of temperature is degrees Celsius, because it's mostly found to be in degree Fahrenheit for some reason. Press the convert unit and make sure that it is in degrees Celsius before you type in 4 there, otherwise your answer is definitely going to go wrong. Right, now let's now go all the way down to calibrated airspeed, which is 120 knots, and in here you also have to enter pressure altitude. Remember, 55 is the flight level, so pressure altitude is 5,500 feet, so 5500, and that is going to give you true airspeed all of a sudden, 13012. So true airspeed is equal to 130.12 knots. You can write it as 130 knots, that's fine, but I kind of take the values until the very last point where I would kind of round it. So the TAS is 130 knots. So that's it. We have kind of found out the fourth element. Now we have the track, now we have the wind direction, wind speed, and we have the true airspeed. Now let's navigate to the wind correction tab all the way down. And from the wind correction tab, the good thing with CX3 again is that your TAS, which you just found out, is kind of stored and displayed right in the wind correction section. So you don't have to memorize or write it down. So TAS being there, let's go to true course, which is 45 degrees. Wind speed and wind direction. So I have kind of overemphasized about this in the previous video. It's very, very important that you punch in the right value in the right row, right? So here it's 190 is the direction and 30 is the speed. So let's put that in 30 here, and then we have 190 as the direction. Remember, winds, unless it is mentioned as winds obtained from ATC or from ATIS, they are all true. Winds from forecast reports, all those are true winds, and for that reason, you don't necessarily have to mention it as true, so you can definitely enter the value straight, true course and true wind. right? Let's press that, or let's hit that orange button, and that's going to give you the ground speed, 153.5 knots. That's it. So we have the ground speed. (153.5 knots), right? And we have the heading is 53 degrees. Now, something we should be careful about here is that we have kind of found out this heading. We have kind of found out this heading using true course. Yeah, it's true course, right? So the heading which we have obtained here is again the true heading, right? What they have asked in the question is the magnetic heading which goes into the aircraft. And so what we do is the day before the flight or the early morning, the same day, you have the charts with you, kind of draw the track, and whatever you draw on your chart is more likely your true course or the true track, right? And then we take that true value and you instantly apply the variation there. One of the things which at least the initial students might kind of forget to do it, you have to apply the variation, because whatever goes on the aircraft has to be magnetic, right? So either you can apply the variation at the true course, or you can apply the variation to your heading at the very end. It's up to you, but you have to apply variation at some point of your calculation, which you should not forget, right? So you take the true course from your chart, you measure using a protractor, and then you have the wind from the forecast, you have the METARs, you have the TAF, you will be having the upper level wind charts and stuff. So depending upon your cruising levels, you can choose the wind, and remember that all those winds are true winds, and therefore you have to again apply your variation to those true winds. So what you can do is you can keep the course as true course, you can keep the wind as true wind, and apply the variation once to the heading, right? So you have the true course, you have the wind. The TAS is kind of generally standard for a training aircraft, for an aircraft as such, and therefore using all those values, using your CX3 or using your wrist wheel, depending upon where you fly, you can kind of find out your ground speed and your heading. And remember, if you haven't applied variation at any of these stages, you have to apply variation here, because the heading which you have now obtained is true. Now, how do you apply variation? The variation given in the question is 15 degrees west. So it's 15 degrees west variation, and the very famous mnemonic is when the variation is west, your magnetic is best, which means you have to kind of, yeah, that's it, you have to kind of add it. So how much do you get? 68 degrees magnetic, right? This is your magnetic heading. And this is the one that goes into the aircraft, because aircraft does not know about true, it is least bothered about the shape geometry of the earth. I'm not talking about the INSAR systems here, but basic systems, not really aware of the structure of the earth at all. And this is a heading that goes to the aircraft, right? Now, the significance of heading is that, as we have discussed earlier, when you have a wind, obviously you'll be having a wind. Nil wind condition is more like a hypothetical scenario. So for the wind, if you want to remain on the required track, you have to fly the heading into the wind. And you can see here, our track is 045, which is true track. Look at the true heading. It is 53 degrees. There's kind of difference of, say, 8 degrees between heading and track. And you can see heading is more than the track. And that goes in line with what we kind of inferred in the beginning. Heading is more than track because you have a port drift. Now, what is the drift here? So since the heading, which is right here, is 053 degrees true, the drift is the angle measured between the heading and the track. Remember, from the heading. That's also important. It's always measured from the heading. And since the difference between 04553 is 8 degrees, now we have 8 degrees of drift angle, which is called as drift. And since the track is to the left of the heading, the drift is going to be 8 degrees port or 8 degrees left. Right? Now look at ground speed. Now why is ground speed significant? We got the ground speed as 153.5 knots. And how is that significant here? Ground speed is the actual track of the aircraft. Ground speed gives the actual track of the aircraft on the ground. Right? How far you travel on the ground depends on the ground speed, not the true airspeed, because we have the influence of wind here. And we established a fact here that since the aircraft has a tailwind, the ground speed is going to be more than the true airspeed. Look at the true airspeed that we got here is 130.12 or 130 knots. Look at the ground speed here. It's 153 knots. Approximately we have a tailwind of 23 knots, right? Quite favorable, but yeah, we have a tailwind, and therefore the ground speed is actually more. Again, that goes in line with what we kind of inferred in the beginning. All right, I hope that makes sense. Now, why is ground speed significant? As I told you, it's the actual, it's a track of the actual travel of the aircraft, and therefore the fuel consumption, your estimated elapsed time, your ETAs, your time estimates will all largely depend upon your ground speed. So when you actually do your flights, there's something called as ground, time map ground, when if you're doing a proper VFR flight. And in that case, ground speed is very, very handy because you can kind of forecast your position ahead of time if you have the proper ground speed. All right. Now, one more thing which I need to kind of bring into your attention, because when I largely got confused when I started flying here in India, because I did my training largely outside. So when I flew in India, it was quite surprising that the track which they consider was 45 degrees, and they took the same track into the aircraft, which means, take for example, that the heading which they found out, say for example, so in India, remember that there is no variation. The variation is 0 because it largely India lies on this in the agonic line where you have 0 degree variation, and for that reason, whatever true value you get is exactly equal to the magnetic value. But that does not mean that you don't have to consider variation, especially if you're flying in a foreign country. You will understand that applying variation is an integral part of your pre-flight calculation. Alright, perfect, that's it. If you have understood this question, I'm pretty happy. I'm quite amazed by the response that you've given me right here, because this question was pretty simple when I explained it the very first time, but it had really happened that I got some good number of doubts. Simple doubts, but I was pretty amazed. I was pretty amazed by the fact that even with this question being very, very simple, students do kind of fumble a bit. And let me bring into your attention to a couple of places where usually students go wrong. Number one is when you consider the wind, and when you enter that into your CX3, they kind of swap it out, right? Number two, they get stuck here on how to find the TAS, especially you can see here, true airspeed is not, outside temperature is not given the question. So such kind of minor things can be a problem. Applying the variation, you might forget to do that. So all these things can be minor problems. So this question is not a standalone question. It has a lot of other theories coming from here and there, and very, very commonly asked type of question for the exams, especially if you're preparing for your CPLs, your ATPLs even, especially a couple of previous exams. There was a bunch of like 4 or 5 questions exactly the same type, and few of them even repeating even the numericals as well, right? So that's it. So if we have understood this question, let's move on to the next one. So let's kind of catch hold on to a different type of question.